G'day team, I'm Phil from Search and Rescue Services. We provide training in a variety of different rescue courses and first aid. This topic's going to be on mechanical advantage. It's also known in the industry as MA, mechanical advantage. So if you're hearing the term MA, it is for that. It's going to be a bit confusing to start with, but as we progress further into it, it's going to come to you bit by bit. So mechanical advantage is a way of gaining some effort in a system, and in a rescue scenario, we will use this to haul up people from a cliff, an embankment, somewhere similar to that, where we need to have a bit of extra power behind us. A lot of times we're pulling using our hands. So here goes some mechanical advantage info. That side there is going to be our anchor. It's just a seat at the moment. Over here is a bag, and that'll be our load. So that'll be the person at the bottom of the cliff we're about to haul up. Just a single figure of 8 on a bite here. I'm going to clip it into the load. And here's our first example of mechanical advantage. By me pulling that load, this is a mechanical advantage of 1 to 1. For every effort I put in here, the same effort's going to be down there. Instead of using the word effort, let's call it tension. How much tension am I putting into that load? Whatever tension I pull here will equal down there, 1 to 1 mechanical advantage. If I change the end over and have it connected to my anchor, and I put in a pulley, clip the pulley into the load, and I pull here, this is a mechanical advantage of 2 to 1. Another way of thinking about it, if I was hanging onto this line and a friend, another person was hanging onto that line, we would have had half the amount of weight of the load. If that load weighs 100 kilos, I'm holding 50, the other person is holding 50. But instead of using that other person to hold the load, I'm just going to tie the end off and make a tree hold the load. So the tree's holding 50, I'm holding 50 kilos, the weight is 100 kilos. This is a 2 to 1 mechanical advantage. When we talk about pulleys traveling with a load, you're going to hear me say that a lot. At the moment, as I pull here, that pulley is traveling with the load. It's moving towards me. So that is a mechanical advantage of 2 to 1. Anytime you've got a traveling pulley, it is a 2 to 1. When I put a pulley in up this end, whenever a pulley is connected to the anchor and the anchor is not moving and that pulley is not moving, that is just a change of direction. Traveling pulley 2 to 1, a pulley that's not moving anywhere, it's attached to an anchor point, is a change of direction. It's not a mechanical advantage. So here is a 2 to 1. The 2 to 1 travels up through a stationary pulley and comes out this side. This is still a 2 to 1 system. I'm going to put the pulley back up this end. This end connects to the load. If I was to send this down, and I put a pulley on this end and I attach it to the load, this is a 3 to 1. Okay, what we've got here is a traveling pulley, which is a 2 to 1, plus my original effort that's gone into it. All right, a little bit hard to explain here, but I'm going to start calculating the tension method. Okay, when we talk about tension, it's the same as effort. How much effort am I putting in? Okay, how many kilos am I pulling? let's just call it a tension. It could be any weight. So whatever pulling power I pull in here, that way, that pulling power, the tension goes in, tension comes out. Okay, so one goes in, the same comes out. Whatever goes into a pulley comes back out of the pulley. So 1 in, 1 out. 1 plus 1 is 2. That is a 2 to 1. The same effort, the tension goes all the way down and all the way back out through that pulley. This is the same tension as well. Okay, so 1 tension in, 1 tension out, 1 plus 1 is 2. 1 continues down, 1 continues up. There's 1. So we've got a 2 to 1 plus a 1 to 1. There's our 3 to 1. A lot of time on a rescue site, we can't really send that pulley down to the victim without causing a few issues. So a lot of times we are simply doing this. We're creating a connection point onto this line here. Here I've got a wrap 3. Correction, it's a 3 wrap prusik. There it is there. So that's my way of connecting to the rope. Okay, instead of the connection happening down there, I'm connecting it here. Pulley goes in. Here is my tension method of counting. 1 goes in, 1 comes out. 1 goes all the way down, 1 comes all the way back up. 1 plus 1 is 2. 2 plus 1 is 3. So this is a 3 to 1 mechanical advantage. Let's say I've increased the load. 3 to 1 is generally the one you're going to be setting up first of all at a rescue site. Now that'll be your first go-to mechanical advantage. What I'm doing now is creating more loops. The more loops you put in a system, the better mechanical advantage you're going to get. Just to make it easier, I'll take these single pulleys out and introduce double pulleys now. Here we go. This is actually a 5 to 1 mechanical advantage pulley system. It's quite easy to see how it is, and this is the second method you may choose to use on a rescue site, going from a 3 to 1 up to a 5 to 1. Realistically, you don't really want to be going much more than a 5 to 1 unless you've got someone there with a bit of knowledge to know what you're doing. So here we go. Let's count the tension method of counting. 1 tension goes in, 1 tension comes out. 1 plus 1 is 2, so I've got a 2 to 1 here at the moment. But because our initial 1 to 1 goes in, 1 comes out, 1 goes down, 1 comes back up, 1 goes in, 1 comes out. So that's another 2. 1 plus 1 is 2, 1 plus 1 is 2, so I've got a 4 to 1. But our original effort continues through the system and pops out the other end. So 4 plus 1 is 5. This is a simple 5 to 1 mechanical advantage. The only times you can start counting lines, for example, counting lines is 1, 2, 3, 4, 5, is when all of the pulleys, these, travel at the same speed. Okay, what I mean by that, one could be traveling faster than the other, and I'll give you an example of that one. Let's say I just drop this one out. Normally you'd never run a double pulley in just a single rope. Okay, just ignore that one for a second. If I've put, that's the correct one. So if I put a rope grab on here, a rope grab is just a term we use for ability to grab rope. In this case, it's a prusik. Let's say I've got, here we go, I do have another pulley. This one goes in, single pulley in there. Pretend that one's a single pulley. You'd never run a double pulley in this situation, just to save the ease of me pulling it apart. Here you're going to see pulleys travelling at different speeds. I'll need to put a bit of weight on the anchor so I don't pull it apart. Here we go. So you'll notice this one, the pulley here, is travelling to me faster than that other pulley. Okay, this is where you can't count lines, because if I was to count lines here, 1, 2, 3, 4, 5, this would indicate it's a 5 to 1, but it's not. It's actually a 9 to 1. Let's calculate that using the tension method of counting. 1 goes in, 1 comes out. 1 plus 1 is 2, so I've got 2 here. 1 continues down through here, goes through there, 1 goes up, 2 plus 1 is 3. I've got 3 on this line. Remember, what goes in comes out the other side. 3. 3 goes in, 3 comes out. 3 plus 3 is 6. So that's a 6 to 1 here. But the 3 to 1 now continues down and comes back up. So 6 plus 3 is 9. So this is a 9 to 1 mechanical advantage. A little bit confusing, but as long as you follow that simple system, you can solve many things. Let's go back through and I'll really mess with your heads a little bit. Let's say I've got another pulley down here and I'm going to clip into another pulley here. I'll just clip it into that same one. Here we go. So 1 goes in, 1 comes out. 1 plus 1 is 2. 1 goes in, 1 comes out. 1 plus 1 is 2. So I've got a 4 to 1 here. 4 plus my original 1. 4 plus 1 is 5. Here we go. 5 goes in. 5 comes out. 5 plus 5 is 10. So that's 10. 5 goes down. 5 comes back. Okay, 10 plus 5 is now 15. Here we've got a 15 to 1 mechanical advantage using the tension method of counting. Let's start pulling this apart a little bit and we'll make it getting a little bit simpler again. So another little key takeaway point I'd like to raise with you is that any time this end, the knot end, anytime that starts at the load, okay, the person, the car, whatever, the part you're lifting up the load, anytime that this knot starts with the load, the system always has to be an odd number. Think about this. The person at the bottom of the cliff, they were in the wrong spot, they've stuffed up. They're the odd person out of the whole group. So if that knot starts with the load, the system has to be odd, as in 1 to 1, 3 to 1, 5 to 1, 7 to 1, 9 to 1, etc. Anytime that knot here is connected to the anchor point, the system always has to be even. 2 to 1, 4 to 1, 6 to 1, 8 to 1, 10 to 1, etc. That's another little point we can try and remember. Okay, so generally what's going to happen on a rescue job, this is the system you will mostly be building 99 out of 100 times at a job. You're going to be setting up a 3 to 1 or a 5 to 1. Okay. So a 3 to 1, it's an odd number. So the knot needs to be down with the odd person or the load. So what it's going to look like, a simple 3 to 1 is going to be like this. Normally, you're going to be running some sort of belaying device descender like this, like a clutch or an ID or an MPD. That'll be there. That'll be your first pulley. So let's do that. Instead of using these, we're going to be using a clutch, for example. Okay, here we go. We're going to load the clutch in. So you'll notice that this clutch has a pulley in it that's very efficient. It's quite a big pulley. It turns. And when it catches the load, it's what's called a progress capture. So if I let go of this end, the system will grab and pinch that rope, locking it off. So it's a progress capture. It's a safety device. So this is our pulley in here, replacing the pulley that we just had. Just going to make it fit a bit better here. There we go. So that is our first pulley. So at the moment, tell me what mechanical advantage I'm doing here. That, the clutch is acting as the first pulley. Is that pulley traveling with the load? No, it's fixed to the anchor point. So that is not a mechanical advantage. It's a change of direction. So we're changing the direction, and then we're going to put in our first pulley here. This is exactly how you're going to set it up on a job for a vertical rescue, for example. Here is your first 3-to-1 mechanical advantage. Screw my carabiners up. There it is there. Simple 3-to-1. 1 in, 1 out. 1 plus 1 is 2. 1 goes down, 1 comes up. 2 plus 1 is 3. A 3-to-1. If you want to build a 5-to-1, okay, an easy way to do it is to take this one off like that. Do what I do here. Like that. And then that leaves you 2 loops down here now. Those 2 loops I can put into a pulley. There and there. Now on this particular device, on the clutch, it's got what's called a becket. That little thing there, it's a hole at the top of the system. An ID, a Petzl ID, won't have that. An MPD does, a clutch does. So I can utilise that becket to create the turning point for my pulley this end. So now I've converted a 3-to-1 into a 5-to-1 very fast and effectively without getting it stuffed up. You'll notice that these loops aren't crossed over. What I mean by crossed over is if you accidentally do this to them, do little twists and stuff, that's going to create rope friction through the mechanical advantage, the MA, making it harder for you to pull. So what I recommend is anytime you're going to load one of these, make sure you're creating nice circles that are climbing upwards to the sky. Here we have a 5-to-1. Let's calculate it using the tension method of counting. 1 in. So I start at the end I'm hauling. 1 in, 1 out. 1 goes down, 1 comes back, 1 goes through, 1 goes down, 1 comes back. 1 plus 1 is 2. 1 plus 1 is 2. So that's a 4-to-1. Plus the original 1-to-1 is 5. 4 plus 1 is 5. So that's how you're going to do your simple 5-to-1 mechanical advantage at a rescue site. Things to notice here, we're going to use all carabiners. We're going to make sure they're all screwed up. If you've got screw gates, screwed up, squeeze and tested. Okay, but you will be taught about Archer, but today's not about Archer, it's about mechanical advantage. All right, happy with that? Let's just do something crazy. Let's add in something different. Let's go through, pretend we're going through another pulley there. Let's pretend that. I'm going to put another rope grab on here. Rope grab. It's a 3-wrap prusik. All right, let's pretend, oh no, I've got a pulley there. Let's go into that one. And I'm going to feed that in here. Let's calculate this. All right, just pause the video now if you want to and have a look at what I've done here and work it out in your own head. Okay, if you've paused it, we've just come back now. Let's calculate the mechanical advantage. 1 in, 1 out. 1 plus 1 is 2. The reason we can count that as a 2 because it's a travelling pulley. It's moving with the load. 1 plus 1 is 2. 2 plus 1 is 3. So here we go. That's a 3 to 1. 3 goes in, 3 comes out. 3 plus 3 is 6. 3 goes in, 3 comes out. 3 plus 3 is 6. So 6 and 12. 12 plus 3. Yep. 12, 11, 12, 6, 12, 13, 14, 15. 15 to 1. Okay, so we've turned a 5 to 1. We've added in a 3 to 1. Another way of calculating it, if you really want to, but I don't recommend it, is we've got a 3 to 1 pulling a 5 to 1. So 3 times 5 is 15. All right, so that's another way of calculating it, but I prefer you not to. I prefer you to use the tension method of counting and doing it the long way. Okay, there we go. Hopefully you sort of get that. I'm going to start pulling apart. So what do we learn? Let's go through it. Rule number 1. If this knot starts at the load, the system has to be odd. If that starts at the anchor, the system has to be even. Anytime you've got a pulley travelling with the load, it's a 2 to 1. Any pulley that's fixed to an anchor point isn't a mechanical advantage, it's just a change of direction. All right, so we're looking at pulleys on this end of the system, not at the anchor. We've got rope grabs, prusiks on here. We've got a double pulley there, some single pulleys going on. And that is mechanical advantage in a nutshell. Why wouldn't you go into bigger systems than 5 to 1s? Well, you can. You just got to know what's the impact of what you're doing. Okay, I have done bigger systems, but the safe working load of 11 mil static, we know from your course that you're going to learn, it's 375 kilograms. So we don't want to put anything pulling on that rope more than 375 kilograms. That's its safe working load. You don't want to go over that. An average person would pull a rope individually between 30 and 50 kilograms of pull power. 30 and 50. Let's max that out at 50. If I've got 2 people pulling here into a 5 to 1, so 2 people pulling 50 kilos is 100 kilos. Let's calculate that. 100 in, 100 out. 1 plus 1 is 2. 1 in, 1 out, 2. So it's 400 plus the original 1. 500 kilos of pull power, 2 people pulling this system. This is the theoretical mechanical advantage. It's never going to be that. A simple 3 to 1 that you'd set up has a proper normal pull power of probably a 2.2 to 1. So a 5 to 1, you're not getting 500 kilos here because we're losing efficiency by going back and forth into the pulleys. Pulleys have, they're not perfect pulleys. They've got some sort of slowing down power. Okay, so if you think it like that, you will never overload your system. Normally on a 5 to 1, you probably got 2 or 3 people pulling on it, but we're not putting as much effort in as maximum pull power, so consider that. So we've just discussed mechanical advantage using a 3 to 1, 5 to 1, calculating the tension method of counting. This one I'm going to teach you now is commonly known as a bolt-on mechanical advantage system. Before, the line we were using that's connected to the load was used to create the mechanical advantage system from within its own line. A bolt-on is where we set up a mechanical advantage system away from the main line, and then we walk it in and connect it to the main line to haul it. And when we haul it, we've obviously got to use the progress capture of this to not lose any ground with our mechanical advantage. So here we are. I'm going to build a mechanical advantage system. Let's do it like this. Okay, we're going to go through there. I'm using I think it's like an 8mm diameter rope here. It's only just to create a different colour. Okay, and here we go. We're building this mechanical advantage. Close up all the sleeves. Okay, so here we go. Going back to our simple method of calculating mechanical advantage, we know that these pulleys will be travelling together with the load at the same time. There's no extra pulleys here going at different speeds. So we know that rule, so what allows us to calculate and count lines. 1, 2, 3, 4, 5. So here is a 5-to-1 mechanical advantage. This is the bolt-on part. So we built a mechanical advantage 5-to-1. This is the load we're hauling, and we want to haul the load up using a bolt-on system. So it's going to look like this. I come in, click it into a progress capture, a rope grab, and then connect it to the anchor. So here we have the bolt-on mechanical advantage that allows us to haul the load, hauling the load, but as we haul it, nothing's progress capturing this line. So what we've got to do is have some sort of progress capture system to offset what we're doing. As we haul in, we want to capture what we're doing. More hauling. Okay, here we go. You'll notice with the 5-to-1, I've got to pull a lot of rope before this goes very little area, very little travel room. So what that means is that for a 5-to-1, I've got to pull 5 meters of rope here for that to move 1 meter. 5-to-1, 5 meters to pull to travel 1 meter. Progress capture, and here we have it. There is your bolt-on. This allows us to take the system out, remove it from the system, and that's it. That's your bolt-on mechanical advantage.